when we multiply two different vectors, and at the end of the day, we have a new vector, then the process of multiplying those two vectors is what we call cross product. Unlike dot product, cross product also possesses two different formulas that helps us to calculate its value. And here are the formula. If A and B are vectors, then A cross B is given as the magnitude of vector A, magnitude of vector B, sine of the angle between vector A and B, then multiplied by a unit vector which is perpendicular to the surface in contact by vector A and B. This formula might seem a little bit weird, so to keep things straightforward, we can take the absolute value of both sides, which is typically the magnitude of A cross B now equals to the magnitude of A, magnitude of B sine theta, then the unit vector. Oops. And this can be furthermore simplified to magnitude of A cos B, then magnitude of A, magnitude of B sine theta, the magnitude of the unit vector. We all know that the magnitude of all unit vector is nothing but 1. So at the end of the day, the magnitude of the cross product of two vectors can be given as the product of individual magnitude multiplied by the sine of the angle between those two vectors. Please make sure you always watch out for that. If you are using this one, then you don't need to multiply your final answer by the unit vector. But if you are using this, then you need to multiply by the unit vector. Perfect. Now, the next question is, how do you determine A cross B, given two vectors A and B to be defined in three-dimensional plane surface? How can we do that? Let's look into that. Consider A to be a vector, and for it to have the following components: x sub 1I plus y sub 1, let me write that properly, plus z sub 1k, and B to have the following components: x sub 2I plus y sub 2j plus z sub 2k. To determine A cross B, we need to use some of the knowledge in matrices. Typically, how to find the determinant of a 3x3 matrix. If it is a 3x3 matrix, we know that it's going to possess 3 rows and 3 columns. So what will be in the first row? Likewise, the second and the third. In the first row, fill the first row with the unit vectors I, j, and k. Then for the second row, let the first vector that tends to be present to be there. So all the components of the first vector should fill up the second row. That's x sub 1, y sub 1, z sub 1. And for the last row, let the last vectors we are having in the cross product to fill in. That's going to be x sub 2, y sub 2, and z sub 2. As we all know in matrices, that if A and B are matrices, then AB is not equal to BA. This also applies to cross products. If A and B are vector, then A cross B is not equals to B cross A. Be very careful of that. Perfect. So now let's continue. So now to find the determinant of this matrix, notice that the I will be associated with positive, while the j will be associated with negative, and the k will be associated with positive. So now, trying to simplify the 3x3 matrix, you begin with I. Then all you need to do is to exclude the first row. Now you want to exclude all the elements in the same column as I, then include all the elements left over. That's y1, z1, y2, Z2. Perfect. Now we have negative J. To include negative, to simplify that of negative J, we have to exclude all the elements in the same column as that of J, while we include the one left over. And that's going to be x sub 1, x sub 2, z sub 1, z sub 2. Perfect. And lastly is that of positive k. So we should exclude everything below it while we include everything aside it. So that's going to be x sub 1, y sub 1, x sub 2, y sub 2. Then we are just going to find the determinant of this. You know that that's going to be I in the bracket of y1 z2 minus z1 y2 and minus j in the bracket of x1 z2 minus x2 z1 and lastly plus k in the bracket of x1 y2 minus x2 y1. Then just simplify this, then you have your final answer. And in the end, just multiply them with k, and that will be everything. Let's consider an example in order to understand what we have been saying in Excel. Consider two vectors, vector A, to have the following components: 4i plus 3j, then plus 2k. And that of vector B to have the following components: 3i plus 4k. We are not given the component for the j-axis. In a case like this, assume you are having 0j as the component for the j-axis. Okay, just keep that in mind. In case whereby you are not given the component of a certain axis, then assume that component is 0. Good. So now let's find A equals B. To find A equals B, we need to set up a 3 by 3 matrices, whereby the first row will be full of the unit vector ijk, and the second row will be the components of the first vector A. That's going to be 4, positive 3, positive 2. And the last row will be the component for this. And that's going to be nothing but 340, 304, because the j comes first. Okay, to avoid the confusion, let me write it anyway. That is going to be plus 0j plus 4k. Perfect. Now we can find the determinant of the matrix. So the determinant of the matrix A equals B. Okay, let me try to remove the absolute symbol so that you won't be thinking that after finding the cross product, you won't need to find the absolute value like the magnitude anymore. You need to find the magnitude in case it is required. So A cross B will be equals to I, then in a bracket. So exclude all the elements in the same row as that of I. Include everything left over. That is going to be 3204. The negative j. Okay, you might be wondering where is the negative coming from. Well, that's just how a 3 by 3 matrix is being simplified in terms of determinants. The first one will be positive, second one will be negative, third one will be positive is a 4 by 4, the next one will be negative. It will keep on alternating. That's just how it works. Okay, hopefully that helps. So open a bracket, then exclude all the elements in the same row as that of j, while you include what are left overs. So that's going to be 4, 2, 3, and 4. Okay, then for the last one, with that of k, you exclude it plus k, then in a bracket of 4, 3, 3, 0. Perfect. Now we can find the determinants. So that's going to be I in the bracket of 3 times 4. You multiply this, and you subtract the product of this from it. 3 times 4 is 12 minus 0 minus j in the bracket of 4 times 4 is 16 minus 6, then plus k in the bracket of 4 times 0 is 0 minus 9. So that's going to be in the end 12i minus 10j, then plus typically negative 9k. And this is the product of the two vector a and b. Now, what if we are to find or determine the angle between the two vectors given the corresponding vectors? What are we expected to do? Let's say we are given two vectors p and q. P to be defined as I plus 2j, then plus 2k, while q to have the following components: 2i plus 3j, then minus k. How can we determine the angle between vector p and q? Well, all we need to do is to make use of the formula. The formula says that the magnitude of the cross product of vector p and q is indeed equals to the product of the magnitude of the individual vectors p and q, then multiplied by the sine of angle between them. So dividing through by the product of the individual magnitude, then we can clearly see that in the end we will be able to determine the angle between them. And this is the formula to use. So we have a lot to cover. First, we will need to get the cross product of the two vectors. Then we will need to find the magnitude of each of those vectors one after the other. Without any further ado, let's get right into it. First, let's find the cross product of P and Q. So let's set up the 3 by 3 matrix. In the first row is for the unit vectors I, j, k. The second row is for the first vector that tends to occur, that's vector p, and it's have the following components 1, 2, and 2. And for the third one, which is the last one, that's going to be 2, 3, and negative 1. Those are the components of it. That's 2, positive 3, and negative 1. Perfect. So now we can begin the simplification. So for I, we have its own 2 by 2 matrix to be full of 2's, 3, and negative 1. And for negative j, its own matrix is 1, 2, 2, negative 1. By now, you should have been familiar with the way I'm selecting those elements. What I will do is that I will ignore the element below the unit vector I took, then just fill in the space with the ones left over, depending on their position, depending on how they tends to occur. Perfect. Then plus k, we have it to be this. That's going to be 1, 2, 2, and 3. Perfect. Now we can determine the determinant. So we have I in the bracket of 2 times negative 1, that's negative 2, 3 times 2, negative 6, minus j in the bracket of 1 times negative 1, negative 1, 2 times 2, negative 4, then plus k in the bracket of 3 times 1, that's 3, minus 2 times 2, that's 4. Now we have I in the bracket of negative 8, then minus j in the bracket of negative 5, then plus k in the bracket of negative 1. And finally, if we expand that, we will end up having the new vector to be negative 8i, positive 5j, negative k. Perfect. Now is to determine the magnitude of the cross product. We eventually got the cross product to be negative 8i plus 5j minus k. Right? Perfect. So let me get rid of this. To determine the magnitude of the cross product of the two vectors p and q, all we need to do is to take the root of the sum of the square of the components present in that vector. So the components are negative 8, positive 5 squared, then negative 1 squared. Simplifying this, we have square root of 64 plus 25, then plus 1. And finally, that is just 64 plus 1 is 65, plus 20 is 85, plus 5 is square root of 90. So can we simplify that to the lowest term? We actually can by just turning 90 to 9 times 10. And finally, that's just going to be 3 root 10. Perfect. How did I get 3 root 10? I turned root of 90 to root of 9 times 10. Now, according to some of the properties of sword, we can take the root of this perfect square, bring it outside, and leave the non-perfect square inside the square root. And that is how I got that. So now we should determine the magnitude of individual vector. What will be the magnitude of vector p? That will be the root of the sum of the square of its components. That's 1 squared plus 2 squared plus 2 squared. And that is just 1 plus 4 plus 4. And that is the root of 9, which is in equals to 3. And the absolute value, which is the magnitude of q, is 2 squared plus 3 squared plus negative 1 squared, which is the same as 4 plus 9 plus 1. And that's going to be equals to the root of 14, which we can actually simplify to the lowest term. So now we can determine the angle between vector p and q. So the angle between vector p and q, sine theta, will now be equals. We said it's equals to this right here, the magnitude of the cross product of the two vectors, that's the root of 90, all divided by the product of the individual magnitude, that's 3 times root 14. So I'm just going to type this into my calculator as a whole in order to get my answer in no time. And I got 0.845. So the next thing in order to determine the final answer for the value of theta is to take the arc sine of both sides. So what will be the arc sine of 0.845? Okay, that's nothing but 57.89. Okay, 69 degree. And that is our final answer to this problem. Hopefully you find this helpful, and hopefully you now know how to find the cross product of two vectors, how to find the angle between those two vectors, and how to find the magnitude of a certain vector. Now there's one more thing that is very, very important that we want you to be familiar with, and that is problem that involves perpendicularity and parallelism. If A and B are vectors, if A and B are parallel to each other, then what will be their cross products? Their cross products will be the magnitude of A multiplied by magnitude of B, then the sine of 0. When two vectors are parallel to each other, the angle subtended by those vectors will be 0 because there won't be an angle between them. Okay, the angle between them will be 0. But the sine of 0 is indeed equals to 0, and that 0 will affect the whole thing or the whole term at the right hand side here, and left over will be A equals B equals 0. So which you want to keep in mind when you have a problem that involves two vectors to be parallel to each other. if you are to do anything about cross product, know that their cross product will end up being zero. Now, what if they are perpendicular to each other? When two vectors are perpendicular, the angle between them is 90. However, the sine of 90 is indeed equals to 1. So therefore, when two vectors are perpendicular to each other, then their cross product will be the product of the individual magnitude or modulus. Hopefully you find this helpful. Thanks for watching. See you guys in the next video. Bye for now.